This video will cover section number 4 in your Unit 8 Trigonometry flipbook. We will be covering just the right-hand column, of this particular section. So let's take a look at the essential question first. It is, what are the rules of 45, 45, 90 and 30, 60, 90 triangles? Now we're going to be covering in this video just the 45, 45, 90 triangles, and in the next video we'll take a look at 30, 60, 90. So why these particular triangles? Why are they so important? And I'll tell you, I used these two types of triangles all the time when I was doing measurements and verifying right angles and other things when I was building swimming pools. So they are commonly used out in architecture and out in the field when you're doing measurements. Where do these triangles come from? So the 45, 45, 90, let's take a look at this particular shape right here. I'll tell you right now, this is a square. This is a square. And if you take a ruler class and go ahead and draw a line segment from the upper left-hand corner of your square to the lower right-hand corner. I'm going to go ahead and make that a little bit thinner here if I can. Not that thin. And there we go. And what you see, class, is if you divide a square up by drawing a diagonal, you actually create a 45, 45, 90 triangle. And here's the reason why. Because we know that the angles of a square are 90 degrees. You can basically show every one of these angles is 90 degrees. And we know that the sides of a square are congruent. Let's just make up a measurement here. So I'm going to go ahead and just make up, let's say that all the sides of this square are 8 units long. Alright, when we divide this square in half, what happens is we end up getting a triangle that actually has angle measures of 45 degrees, and then of course this right angle hasn't changed, and then this angle is 45 degrees as well. And the reason why is because when you draw a diagonal in a square, you bisect or cut in half the upper left and the lower right hand angles. So we end up with this 45, 45, 90 triangle. Now of course we know this side is still 8 and this side is still 8. What we want to be able to do, class, is figure out what the length of the hypotenuse is without having to use a Pythagorean theorem. But in the beginning we got to use Pythagorean theorem, and then we're going to learn a shortcut where we can find the length of the hypotenuse without using or going through the process of using the Pythagorean theorem. Let's go ahead and label the vertices of this triangle A, B, and C. And let's go ahead and find the length of AB. Let's see what it is. So I'll put down here, let's go ahead and find side AB. Well, we're going to use Pythagorean theorem because we have a right triangle. So we're going to go ahead and go 8 squared plus 8 squared equals C squared. That's because one of our legs is 8, the other leg is 8, and C is going to be our hypotenuse. If we square these numbers, we get 64 plus 64 equals C squared. So we find out that 128 equals C squared. We're going to square root both sides, and we're going to end up with C equals the square root of 128. Now, we're not going to put this in our calculator. In the beginning of this semester, we talked about how to simplify a radical or simplify a square root. Let's go ahead and simplify this. So we found that the value of C, of side C, which is our hypotenuse, is square root of 128. We can simplify that by dividing it into some of its factors. And I know, class, that 128 is just 64 times 2. So that means we can write this as the square root of 64 times the square root of 2. Remember, these two numbers are still in the radical, we just separated them. And we know the square root of 64 is just 8. So the value of the length of the hypotenuse, AB, is 8 times the square root of 2. So let's write that right here. 8 times the square root of 2. Now what we find, class, is no matter what size our 45, 45, 90 triangle is, whatever the side lengths are, or the leg lengths are, the hypotenuse will always be that same number times the square root of 2. So if we have a 45, 45, 90 triangle, and this side is 10, and this side is 10, the hypotenuse will be 10 times the square root of 2. If this side is 50, and this side is 50, then the hypotenuse will be 50 times the square root of 2. So we have learned a shortcut for finding the side lengths of a 45, 45, 90 triangle. Let's go ahead and write this now as a rule. So down here below, let's write this as a rule. Here is a 45, 45, 90 triangle. Let's go ahead and label this as 45 degrees. Class, you know we don't have to label this one 45. We know it has to be 45 because 180 minus 90 minus 45 equals 45 degrees. Here is our rule. Whatever this side is, this leg, x, this leg will also be x, and this leg will be x times the square root of 2. The way to write this would be, class, is the legs, if the legs of a 45, 45, 90 triangle are x, then the hypotenuse is going to be x times the square root of 2. And one more thing to notice here, class, since the legs of our right triangle are always the same length, that means that a 45, 45, 90 triangle is isosceles. It's an isosceles triangle because we cut it out of a square, and that means that these two sides the two legs came from the square. They must be the same length. All right, now with this rule right here, class, we can find the sides of a 45, 45, 90 triangle very quickly. Let's take a look at an example. Here's our first one. Find the missing side measures. Well, here's a 45, 45, 90 triangle. We know the length of this side is 26 feet. Let's write our rule real quick. The legs of a 45, 90, actually let's put legs here. The legs of a 45, 45, 90 triangle can be x. That means the hypotenuse is going to be x times the square root of 2. All right, let's take a look at our triangle. We're given the measure of one of the legs. That means if the legs are x, that means x equals 26. So we already know what x is because the leg value is x. So this is 26 feet. Now I'll just put an x there so you recognize that's x. Let's go ahead and put down here, we know this is also going to be x, and this is going to be x times the square root of 2. So we already know that this side is 26 feet. Now we just figured out, of course, that this side is also going to be 26 feet because this is an isosceles triangle. And now let's figure out the length of the hypotenuse. We know the hypotenuse is going to be equal to x times the square root of 2. That means it's going to be 26, because x is 26, times the square root of 2. And if we plug that into our calculator, let's do that right now. I've got a bunch of things here. Let's reduce this down and see if I can find my calculator. Okay, there we go. There's our calculator. Let's go ahead and put this in. 26 times the square root of 2. Close that parentheses and press equal. And we've got 36.76. We can round that to 36.8. 36.8, and that is the length of our hypotenuse. Let's go ahead and fill that in here. So let's write our final measurement. This is approximately 36.8, and of course that is also in feet. So when you get good at this, you can calculate this in your head and just throw this in your calculator, or just leave it as the 26 times the square root of 2. It's much faster than using the Pythagorean theorem. And I'll go ahead and circle this answer so we know we found the hypotenuse. And I'll circle this because we know we found the length of the legs. All right, let's try this one more time. Find the missing side measures. Oh, in this case, they gave us the hypotenuse. Let's set up our rules first. We know in a 45, 45, 90 triangle, the legs are going to be equal to x. If they are, then the hypotenuse is going to be x times the square root of 2. Now in this case, we know, again, let's label this. This is going to be x. This is going to be x. This is going to be x times the square root of 2. Well, we know our hypotenuse is 12. So that means we can write this statement. X times the square root of 2 is equal to 12. You see what I did? I took the rule for the hypotenuse and set it equal to its known measure. Now we got to get x by itself. And the way we do that is we divide both sides by the square root of 2. These will cancel. And we end up with x equals 12 divided by the square root of 2. And if we put that in our calculator, that is going to be approximately, let's take a look. 12 divided by the square root of 2. And we've got 8.48. We can round that to 8.5. So it's approximately 8.5. So that means we know, class, that the sides of this 45, 45, 90 triangle are approximately 8.5 centimeters. Let's go ahead and write those in. So this is going to be 8.5 centimeters. And of course this side is also 8.5 centimeters because of an isosceles triangle, the legs are the exact same length. So by setting up our triangle this way, writing down what we know and find the value of x, with the value of x we can find anything. We can find the leg lengths, and of course we already know what the hypotenuse is up here. We knew what the leg was. We can then plug that in, the x value, and find the hypotenuse. So that is how you find the missing side measures of a 45, 45, 90 triangle.